Occupational internal dosimetry has been made much easier by using dose conversion factors, which are also called dose coefficients. Dose coefficients relate any committed dose equivalent to an intake activity. Multiplying a known intake by the appropriate dose coefficient in sieverts per becquerel or millirems per microcurie results in a committed dose equivalent to a tissue or organ, or a committed effective dose equivalent. Dose coefficients are found in a number of publications. Those found in Federal Guidance Report Number 11, or FGR 11, are based on ICRP 26, ICRP 30 methodologies, models, and recommendations. In contrast, coefficients published in the latest compendium, ICRP Publication 119, are based on ICRP 60 methodologies and recommendations. FGR 11 begins with an introduction and information about ICRP's 1977 recommendations. It also includes derived guides for ingestion and inhalation, the annual limits on intake, and derived air concentrations. The ALIs and DACs in FGR 11 are the same as those in ICRP 30, except for a few that were computed using more recent metabolic information. FGR 11 includes updates to the respiratory and gastrointestinal tract models, which incorporate the improvements made in metabolic modeling and physiological data since the issuance of ICRP 2. FGR 11 also includes the dose conversion factors for inhaled nuclides in Table 2.1 and the dose conversion factors for ingested nuclides in Table 2.2. Turning to page 128, we see the coefficients for inhaled strontium isotopes listed for various organs. Note that FGR 11 uses the special SI units, sieverts per becquerel. To convert sieverts per becquerel to conventional units of millirem per microcurie, multiply the table entries by 3.7 times 10 to the 9. In these tables, the first column lists the nuclide, the second column shows the solubility or clearance class using the D, W, and Y designations. Remember that organ dose depends strongly on solubility and rates of clearance from the lungs. In general, insoluble class Y materials lead to higher lung doses. The gastrointestinal F1 values are listed in the third column. This is the fractional absorption from the intestine into the bloodstream following inhalation. Looking at the values for the various isotopes of strontium, we see that they range from 0.01 to 0.3. Each of the remaining columns represents dose coefficients for various organs and tissues. In the last column are dose coefficients for calculating the committed effective dose equivalents. The bold entries highlight the limiting coefficient, which was used to determine the ALI or DAC. If we look at Class D strontium-90, the bold entry in the bone surface column indicates that the CDE limit of 50 rems to an organ or tissue will be reached before the CEDE stochastic limit of 5 rems. Conversely, when we look at Class Y strontium-90, the bold entry in the effective column indicates the CEDE limit of 5 rems will be reached before the CDE 50 rem limit to any organ or tissue. As a practice calculation, we'll use FGR 11 to determine a worker's committed dose equivalent to the thyroid gland, following an inhalation intake of 0.5 microcuries of iodine-131. The committed dose coefficients for inhaled iodine-131 are found in Table 2.1 on page 136. Scanning over the dose coefficients, we see that the thyroid gland is the limiting organ. The dose coefficient for inhaled Class D iodine-131 is 2.92 times 10 to the negative 7 sieverts per becquerel. Multiplying the intake of 0.5 microcuries by the dose coefficient and the 3.7 times 10 to the 9 conversion factor results in a committed dose equivalent to the thyroid gland of 540.2 millirems.